specifically going to look at how to make a standard solution, and we're going to look at our titration of sodium carbonate and hydrochloric acid. So our learning intentions are to prepare a standard solution of sodium carbonate and to use a standard solution of sodium carbonate to standardise a given hydrochloric acid solution. So the first thing we'll look at is we'll look at how to prepare a standard solution. Now, this will usually come up as part of a question rather than as an individual question itself. So to prepare a standard solution of sodium carbonate, first thing you need to do is you need to weigh out a known mass of your anhydrous sodium carbonate on a clock glass. The next thing you need to do is you need to add this to a beaker containing deionized water, and it's important to wash the residue of the sodium carbonate off the clock glass into the beaker. The next step is to stir using a stirring rod to dissolve the sodium carbonate. Next is you transfer the solution from the beaker into a volumetric flask using a glass rod and a funnel. You should ensure to rinse any residue off the beaker, funnel and glass rod. The next thing you do is you add deionized water until the bottom of the meniscus is in line with the graduation mark. And the last thing then you do is you stopper and invert 20 times to obtain a homogeneous solution. Now, as I've said, this mainly won't come up by itself. It will come up as part of a titration question. So let's have a look at our first titration that we'll do. Our first titration is the standardization of a hydrochloric acid solution using a standard solution of sodium carbonate. And it's usually in this experiment that you'll be asked, how did you prepare your standard solution of sodium carbonate that I've just gone through? So with all experiments, it's important to look to see what's in the burette, the pipette and conical, the indicator and the endpoint. So in your burette, in this experiment, you've got hydrochloric acid and it's an unknown concentration. In your pipette or your conical flask, what you're going to have is you're going to have sodium carbonate and you're going to have a known concentration of it, and it's going to be 25 centimetres cubed. Your indicator is methyl orange, and the colour change that you're looking for at the end of this experiment is from a yellow to a pink colour. So let's look at some sample questions. These are exam style questions that would come up if this titration was on an exam. So the first one says, describe how the level of the liquid in the burette was adjusted to the 0 mark. So I would always say you would fill above the mark and drain until the bottom of the meniscus is in line with the graduation mark or in line with the 0 mark. It's also important to ensure that the tap is filled. In the second question then, it says, why is a pipette filler used when filling a pipette with 25 centimetres cubed of sodium carbonate? So there's many reasons. It's mainly for safety, for hygiene, and to prevent the solution getting into the mouth. So now let's look at a sample calculation for this experiment. So this is just a condensed version of an exam question, and we're going to go through it. We're going to go through it using the first principles method. So the question says 25 centimetres cubed of 0.05 molar standard solution of sodium carbonate required an average volume of 20.8 centimetres cubed of hydrochloric acid for neutralisation. The reaction has the following balanced equation. Complete the concentration of the hydrochloric acid in moles per litre and in grams per litre. So we're going to do this by first principles, and the important thing to remember is that with first principles there is 3 steps. So the first step asks us to find the concentration of our known standard solution in our titration volume. So we know from the question that we have 0.05 moles of Na2CO3, but that's in 1 litre, but we only have 25 centimetres cubed. So we use our formula, which is the molarity divided by 1,000 and multiplied by your titra volume. So if I fill into that, what I get is I get 0.05, divide that by 1,000, and I multiply by 25 because that's how much of the sodium carbonate I have in my titration. And that gives me that I have 0.00125 moles, and that's in 25 centimetres cubed. So, in the next step, what you do is you look at your balanced equation. So I have Na2CO3 plus 2HCl. So I can see that that is a 1:2 ratio. However, I don't have 1 mole of my sodium carbonate. I have 0.0125 moles. So to figure out how much of the hydrochloric acid I have, I can see here that for every 1 sodium carbonate there is 2 hydrogen chlorides or hydrochloric acids. So that means that there will be twice as much hydrochloric acid. So that gives me that there will be 0.0025 moles of the hydrochloric acid. Now that is in 20.8 centimetres cubed, because the hydrochloric acid has a average titration volume of 20.8 centimetres cubed, as I've just highlighted there in the question. So for step 3 now, you want to find your concentration of your unknown solution in moles per litre, which is the hydrochloric acid. So I know that I have 0.0025 in 20.8 centimetres cubed. So I must fill into the formula that we've learned in our first principles, and that is the moles multiplied by 1000 divided by the titration volume. So I know that I have 0.0025 moles. I multiply 0.12 moles per litre. So that is my final answer for part A, and I've approached it using first principles. So if I now look at part B wants me to find it in grams per litre, and I know to go from moles to grams, what I do is I multiply by the molecular mass. And here we've got the moles of the hydrochloric acid, so we're looking for the molecular mass of hydrochloric acid, and that is 1 plus 35.5, so that's 36.5. So what I do to go from grams to moles is I do 0.12 moles per litre multiplied by 36.5, and that gives me 4.38 grams per litre, and that is my answer then to part B. So I do recommend that you go over this titration and go over this calculation to make sure you understand it, specifically part A here, as it involves using first principles, which is the way that I do recommend you complete titration calculations. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've